to take a look at functions and some of the important concepts that are covered with functions. Let's start by looking at what a function is. A function is going to be a relationship in which every input has one specific output. We are going to take a look at this list of ordered pairs and see whether this relation would actually represent a function. So what we need to do is figure out what the domain and the range are. When we talk about the inputs, we are referring to the domain, and when we talk about the outputs, we are referring to the range. Another way to refer to input and output, input is also considered your x values, and output is considered your y values. So to start with this, we're going to take a look at these ordered pairs, and we're going to write the domain. So we set up these brackets, and we're going to list all of the x values, and we're going to put them in order from lowest to highest. So we are going to have 1, 2, 3, and 4. Now 1 is listed twice, but when you go to write your domain, you only want to put it one time. So if a value for the input is there more than once, just list it once. Now for the range, we're going to do the same thing where we put our brackets, and we're going to go through and we're going to write all of the y values for this list of ordered pairs. So I would have 5, 6, 7, 17, and 28. And close my brackets. Now our question is whether or not this relation represents a function. So we are going to take a look at the inputs and the outputs, and we want to make sure that every input has one specific output. So if I start going through this, I would see that when the input is 1, the output is 5. When it's 2, it's 6. When it's 3, it's 17. And then I get here and see when the input is 1, the output is 7. This is going to make this list of ordered pairs represent something that is not a function, because I have the input of 1 there twice with different outputs. That means this relation does not represent a function. One way to think of functions is to remember them like a vending machine. If a vending machine is working correctly, you would type in numbers. Let's say you type in A1 to get a bag of chips, and you would expect the bag of chips to come out. You wouldn't press A1 and get a candy bar, because then it wouldn't be working properly. So your input should have one specific output. Now, what can happen sometimes is you may have more than one input that have the same output. So I could have A1 and A5 both represent chips, and that would be okay. I just can't have one input giving me different outputs. So hopefully if you get stuck with this, you can think back on the vending machine and it will help you to analyze a relationship and figure out if it truly represents a function. Now next we'll take a look at function notation. We're going to take a look at y equals 3x plus 4, and we are going to write it using function notation. What we're going to do is we're going to take this, which is written in slope-intercept form, which is y equals mx plus b. M represents my slope, and b represents my y-intercept. And in order to write it in function notation, instead of writing y, I'm going to replace it with f of x. So I'm going to have f of x equals 3x plus 4. Now these two problems down here look very similar with the 16s, but they're actually asking us to do very different things. So what we're going to do for this one, when we do f of 16, I am going to go to the original equation right here, and I am going to go from that original of 3x plus 4, and I'm going to have f of 16 equals 3x plus 4. Now what we're going to do at this point is everywhere there is an x, I am going to replace it with 16. So I am now going to have f of 16 equals 3 times 16 plus 4. And at this point, you're going to go through your order of operations. So you've got PEMDAS, or please excuse my dear Aunt Sally, and we would start, first thing we would come across is the multiplication. So 3 times 16 is going to be 48, plus 4 means when I'm evaluating f of 16, my answer is 52. Now when I go to solve f of x equals 16, it's going to be set up a little bit differently. I'm going to go back to my original, and instead of replacing the x with 16, I'm going to replace f of x with 16. So that's like replacing this entire piece right here with 16 equals 3x plus 4. And once you've done that, our goal is now going to be to solve for x. So we're going to walk through and we're going to solve this like we would any other equation. I'm going to start by isolating my variable, which is going to make me need to subtract the 4 from both sides. So let me put subtraction. Right, we're subtracting 4. Whatever we do to one side, we need to make sure we do to the other. And that is now going to leave me with 16 minus 4, which is going to be 12, equals 3x. And now the last step that we need to do to isolate my variable would be to divide both sides by 3. And I'm going to have x equals 4. So you could see two questions that look like they're going to be fairly similar are actually very different. Just be careful when you're reading them. Now we could also look at functions on a graph, which is another way to represent them. So we're going to take a look at this graph right here and answer two different questions. Identify the value of f of x given x equals negative 4. I'm going to take a look at my graph, which is this blue line right here, and I am going to solve for f of x, which is like y, when x is negative 4. So I'm going to go along this blue graph until I find where x equals negative 4, which is going to be right here. At this point right here, my x value is negative 4, and then I need to see what the y value is. So for this particular problem, when x is 4 or negative 4, y is 6. So f of x equals 6. Or we could write it as f of negative 4 equals 6. So when my input is negative 4, my output is 6. One thing to be careful for with these is to make sure that you're checking the scale and seeing whether they're increasing by 1 or 2 or 5. In this case, we're increasing by 1 for every box. Now the second question is to identify the value of x given f of x equals negative 5. So we're going to look at this blue graph again, and this time we're looking where f of x, or y, equals negative 5. So on this blue graph, here's y being negative 5, and that happens right here. And then I would go up and see what my x value is. So in this case, x would be 3. So when x equals 3, f of x equals negative 5. Now let's take a look at a word problem. When dealing with word problems, you want to go through and pick out the important pieces of information. So we're finding the cost to rent a movie from MovieBuster is $3, which is important, plus $1.75 for each day late. How much will you pay for a movie rental if you return it 2 days past due? When we go to set these up, I'm going to use function notation. So we're going to have f of x equals. Now when we set this up, we want to think about slope-intercept form. So you think about y equals mx plus b. The slope is also referred to as your rate of change with these problems. So in this scenario, the rate of change is going to be how much extra I'm having to pay a day. So I'm paying $1.75 more, so it's positive, for every day late. So I'm going to have 1.75x, plus the cost that it took to rent the movie, which was $3, or my constant. So no matter how many days late, I still have to pay $3 to rent the movie. In this case, x is going to represent my number of days, late. So however many days past due, that's going to be what I replace x with. Once we've set up the equation this way, the nice thing is, if they ask me how much I would owe 5 days late or 10 days late, I already have my equation set up, so I could just plug the number in. So for this problem, they wanted to know how much we would owe if it was 2 days past due. So I'm going to replace x with 2 and evaluate my function. So I have f of 2 equals 1.75 times 2 plus 3. Again, go through your order of operations. 1.75 times 2 is going to be $3.50, plus $3, and then I just need to add them together. So $3 plus $3.50 is going to come out to $6.50. And that's going to be the total amount I owe 2 days past due. Now here are a few key vocabulary words that you want to make sure you know for this particular section. X-intercept, y-intercept, initial value, rate of change, and slope. X-intercept is going to also be referred to as where your graph crosses the x-axis. When that happens and it's crossing the x-axis, your y value will be 0. For the y-intercept, you're going to be looking where your graph crosses the y-axis. And in this case, x will be 0. Initial value and y-intercept are actually words or phrases that mean the same thing. So when I'm talking about the y-intercept and the initial value, those represent the same value. Initial value is going to be your starting point or your starting value, and it's the same as your y-intercept. Rate of change and slope also mean the same thing, so I'm actually going to leave them together. Your rate of change and slope have a formula, which is y2 minus y1 over x2 minus x1. That is slope formula, which hopefully you've seen before. We also will refer to it as change in y over change in x, change in output over change in input, just to use some vocabulary. And another common way to refer to it is rise over run. Especially if you're given a graph, rise over run is usually the easiest method. Now let's take a look at another word problem, and this shows us another way we can represent functions, which would be a table. So far we've looked at graphs, lists of ordered pairs, and now we have our table right here. A helicopter is coming in for a landing. The height is shown for each minute it nears the ground. Describe the initial value and rate of change for this linear relationship. After how many minutes will the helicopter reach the ground? So again, you want to go through and look for keywords, and one very important thing to do is make sure you know what you're actually trying to solve for. So we're looking for how many minutes it's going to take for this helicopter to actually land on the ground. Now if we look at our table here, we have the minutes and the height. The minutes are going to represent my x or my input, and the height is going to represent my y or my output. In order to set things up, if you think back to that y equals mx plus b, which we will write in function notation, I am going to need to find the rate of change and the initial value, which was part of what they had asked us to do up here. We're going to describe the initial value, and we are also going to describe what the rate of change is. Now the initial value is where my starting point is. So when my input or my x value was 0, my output was 12,000. That is going to be my initial value. So we don't have to do too much work to get that one. The initial value equals 12,000. To get the rate of change, we're going to do the change in y over change in x, or y2 minus y1 over x2 minus x1. Now you could pick any 2 points and do this. I like to pick 2 that have numbers that are kind of easy to work with. So I am actually going to pick these first 2 points. So I'm going to have this be my x1, and I'm going to have this be my x2. This will be my oops, I didn't mean x2, that is y2. That's my x1, this is my y1. Okay, so we've got x1, and then right here is my y1. This is my x2, and this is my y2. Okay, and that's actually a very important thing to watch out for, because what happens sometimes is people will mix up where the 1s and the 2s go. So you always want to make sure that you're keeping the 1s together and the 2s together. So I have x1 and y1 and x2 and y2. I'm going to plug them into my formula. So I'm going to have 10,500 minus 12,000 over 1 minus 0. And that's why I picked those, because I like the 1 minus 0. And we're going to simplify. So I would do 10,500 minus 12,000, which is going to give me negative 1,500 over 1. Which is the same as just negative 1,500. And that is my rate of change. So now when I go to plug in, I'm going to have f of x equals my slope or rate of change. Now it's negative 1,500 because as time is going on here, the height is going down or decreasing, which is going to result in a negative value. So I'd have f of x equals negative 1,500 x plus the initial value, or 12,000. Now this particular question was asking us what the height or what the minutes will be for the helicopter to reach the ground. When the helicopter is on the ground, the height is going to be 0. So my y value, or f of x, would be 0. So I would plug in 0 for f of x equals negative 1,500x plus 12,000. And I'm going to need to solve this for x to figure out how many minutes have passed. Once you get here, you would subtract the 12,000 from both sides and isolate your variable. Slide this down here. All right, we subtract 12,000. That is then going to leave me with negative 12,000 equals negative 1,500 x, because these values are going to cancel right here. Right, these have canceled, and then we have the negative 12,000. And then once I get here, all I need to do is divide both sides by the negative 1,500. So I'm going to do negative 12,000 divided by negative 1,500. These will cancel out to be 1. And I am going to end up with x equals 8. So 8 minutes is how long it would take for the helicopter to land on the ground. The last thing I want to take a look at is piecewise functions. So this scenario has you were on your way to school when you realized you didn't have your favorite calculator. Here's a graph of your morning. You start out with your distance from school over here, and it's in blocks. So I have my distance in blocks from school, and then down here I have my time in minutes. So when I am first starting my initial value, I am 10 blocks from school. Along this interval, I would be walking towards school, so this is a decreasing graph because as time is going on, my distance from school is decreasing. I get to this point and stop and realize I forgot my calculator, so I have to walk back home. This is increasing along this interval right here because my distance is increasing from school. I am now going back home, which is making me farther from school. This would be a constant because along this interval, my distance is not changing. I am staying in my house looking for the calculator. And then this last interval is decreasing again because my distance from home to school is decreasing. So by the time I get here, I am now 0 school blocks because I am at school. So it took 12 minutes to complete the process, and again, this was decreasing until I finally arrived at school. I hope that you found this helpful and that you now have a better understanding of the topics covered regarding functions.